Today we're going to start the cardiovascular system, and for today we're just going to kind of do a basic overview of the function and the different structures, and next time we'll go over the actual pathway that blood takes in the heart. Okay, so functions. The cardiovascular system is responsible for a couple different things. The first one is going to be that it is responsible for the transport of oxygen, carbon dioxide, nutrients, so food. It's also going to transport the waste that your different body cells produce. And it's also going to help assist in the prevention of infection. So it's going to help you not get sick, and it's going to do that by helping transport leukocytes. So if you remember, those are your white blood cells. And then the last function that we're going to go over is the regulation of body temperature. So it's going to help maintain your body temperature in two ways. The first is known as vasoconstriction. So constriction means, kind of getting smaller. And so it's going to decrease the diameter, so how wide the vessels are. One of the reasons for vasoconstriction, would be like if you're out and it's really, really cold, you need to make sure that you preserve your heat to the internal structure. So like all your essential organs as opposed to like your fingers and stuff like that. Vasoconstriction can also happen even if it's not temperature related. So like let's say you get, some sort of cut, the vessels around the cut are also going to constrict in order to decrease the amount of blood that is lost. And then vasodilation in relation to temperature control is typically seen whenever your body temperature rises. And so what's going to happen is that there's going to be an increase of blood flow to your surface, so to your superficial organs such as your skin. So if you, are starting to get really, really warm, you'll notice that your skin starts to feel hot. You might even, depending on your skin color, you'll see that you start turning red. And that's just because there's an increase of blood flow by, the vessels are getting wider to make sure that you kind of start releasing some of that excess heat that's carried in your blood. All right, some information about the heart that you're going to have to know. The first one is, where is your heart? So hopefully you know that it's in your chest or your thoracic cavity, and it is also slightly to the left. So if you look at this picture down here, you'll see that it is centered, but most of it is kind of to the left side. Your heart is also about the size of your fist. It beats on average between 72 to 82 beats per minute. If you're, very healthy and active, you might even see your heart be at, maybe 50s or the low 60s. And it's okay as long as, it's because of being really, really active. The weight. So women are typically smaller, or in average, they're smaller, and so the weight is smaller. It's about 8 to 10 ounces as opposed to men who are generally bigger, and it's between 10 to 12 ounces in men. Some other heart numbers that you need to be familiar with. The first one is going to be cardiac output. So this is how much blood is pumped per minute. Okay, so cardiac output is per minute. And this is going to help determine how healthy your heart is. So the higher your cardiac output is, the more healthy your heart is. And this is going to be determined by stroke volume. Okay, so stroke volume is per beat. So I would underline that. Cardiac output is per minute, while stroke volume is per beat. So every time that your heart beats, how much blood does it actually pump out? The average cardiac output, so in 1 minute, the average person can pump about 1.3 gallons, or about 4.9 liters. So if you were to do this for the entire day, your heart pumps about 1,900 gallons of blood a day, which is a lot. All right, so structures of the heart. The first is going to be the pericardium. This is the outermost structure. So your heart is in this sort of bubble, and this bubble is meant to help protect it and reduce the wear and tear. So that's the general function of the pericardium. It's going to have this fluid and it's to reduce friction. So your heart is constantly pumping. So there's parts that are rubbing against each other and you don't want them to wear out, because the moment that your heart gets out, that's pretty much the end of your life, which is not good. Okay, so it helps, reduce friction. It also acts kind of like a cushion. So you see this blood on the, or not, sorry, not blood, but this kind of yellow tissue on the outside, which is fat. Fat, that's one of the functions is insulation. So it's okay to have fat on the outside of your heart. You don't want it in your vessels, but it's to also help protect the heart. All right, layers of the heart. So you have the epicardium, which is the outermost layer. Then you have the myo. If you recall, myo means muscle. So this is the muscular layer of the heart. This is the one that actually does the contracting to pump. And then you have the endocardium, which is your innermost layer. This one is kind of also like a lubricant. If you look at this picture, you have the pericardium out here, and you're going to have a little bit of space where you have your fluid that's going to help keep, the friction to a minimum. Then you have your pericardium, which is the outermost layer of the actual heart. And then this thick layer here, this is the myocardium. So this is where you have all your muscle fibers that are going to contract in order to pump blood. And then you have this innermost. You can kind of see that it looks really kind of slick, smooth. And that's, to help make sure that there's, not a lot of friction out here and, keep the blood inside of the heart. And so what I want you to do is I want you to make sure that you have some sort of sketch that kind of shows you the difference in the structures on how they look and the purpose of them. The heart is divided into 4 total chambers. You're going to have 2 atria. So the top 2 chambers, that's where you're going to receive the blood as it's coming in. And then the 2 bottom chambers are the 2 ventricles, and these are the ones that are actually responsible for pumping the blood out of the heart. This is where you'll see that it has a really thick myocardium layer because they're having to pump the blood further, as opposed to the atria that really only have to contract to get the blood to the ventricles. Then you have 4 valves, and so these structures are really, really important because they're going to make sure that there is no backflow. You want the blood to be flowing in one direction so that it's efficient. You have 2 atrioventricular valves, and they're abbreviated as AV valves, and these are going to be kind of where the name says, they're between the atria and the ventricles. The one on the right, we're going to just go by the tricuspid name because it also has other names. So the way that I remember is tri has the RI, and so it's on the right. And then the other one is bicuspid, which is on the left. So tri is right. And then you have 2 semilunar valves. And so these valves are going to be between the ventricles and whatever vessel is going to carry the blood out of the heart. And so the pulmonary valve is on the right side because it's going to be pumped into the lungs. So pulmo is lung. And then you have the aortic valve, which is between the left ventricle and the aorta. You also have these structures known as chordae tendineae, or heartstrings, and they do look like heartstrings. And their job is to hold the atrioventricular valves in place so that whenever the ventricles contract, the blood doesn't go back into the atria. You want the blood to keep going in one direction. And these heartstrings are going to be attached to the heart through the papillary muscles. And so that's what their job is to anchor these heartstrings. And so if you look at this picture, you have the heartstrings here, and they're attached to the heart through these papillary muscles. And their job is just to make sure that the blood doesn't go back this way into the atria whenever these ventricles contract. Okay, and then you can kind of see it on this animation. So when this lower part is contracting, you see how the AV valves over here, they need to be closed. And so these strings basically just make sure that the valves aren't pushed open into the other direction, back into the atria. All right, circulation units. So we know that blood flows all over the body, but it's kind of divided into 3 different circuits. And the first one is going to be pulmonary circulation. So when the blood first arrives into the heart, on the right side, it is deoxygenated. It doesn't have a whole lot of oxygen, so we need to get that taken care of first. So pulmonary circulation basically is just the route that the blood takes from the heart to the lungs to get oxygenated, and then it has to return to the heart. So that's this section here. So you see in blue, blood comes in, then it gets pumped to the lungs, and then from the lungs it's going to return back to the heart. So this first section here in the blue, that is pulmonary circulation. The next step is systemic circulation. So this is the flow of oxygenated blood from the heart to other parts of the body. And so if we were to look back at this picture, so the red here, this would be the systemic circulation. So you can kind of see it on here too. So once blood is oxygenated, it returns to the heart, and that's where systemic circulation starts. So it's pumped from the left ventricle out to the entire body. And then it's going to return back to the heart, and the cycle kind of starts all over again. And then there's one more type of circulation. It's kind of like a sub-circulation circuit from the systemic, which is known as cardiac circulation. Okay. So you might think that the heart is supplied with oxygen, because it's pumping blood, so it kind of just like diffuses into heart muscle, but that's not true. Okay, so oxygen to the heart is not provided by the blood in the chambers. Okay, it has its own set of vessels that are responsible for feeding and supplying, oxygen and all the required nutrients to the heart. Okay, so that's going to be done by these coronary arteries. And so just kind of like a look ahead, typically, one of the reasons why people end up with heart attacks is because there's blocks in these coronary arteries, and so different parts of the muscle or the heart muscle might not be getting oxygen, and so part of the heart tissue dies, and so they suffer a heart attack because their heart isn't getting the appropriate nutrients that it needs. Okay, so oxygen-rich blood is supplied by the coronary arteries, and that's a branch of the aorta. I have to excuse the pups. I don't know, probably saw a squirrel or something. All right, so cardiac cycle. Cardiac cycle is going to be in 2 phases. Okay, so the first one is known as systole, and so this is when the chambers are contracting in order to pump blood out. And then you have the diastole, so the pressure inside of the chambers whenever they're relaxed and they're getting blood back in there. Okay, so you probably have heard of these words whenever you get your blood pressure measured and stuff, but you didn't really know what it meant. So it's just measuring the amount of pressure. And these numbers are used to determine how healthy your heart is. So you don't want your heart and your vessels to be under a lot of pressure. So the optimal one, this is just, one of those numbers where it fluctuates, but it's about 110 over 70, or you sometimes see 120 over 80. So those are okay numbers. But if you start having higher numbers and they're consistent, so not just, after you finish running one lap and then you have high blood pressure. No, if you're resting and you're measuring it over a period of time and it's consistently higher, then that's not so good. because that just means that you're making your heart and your vessels work a little bit harder than they have to. Okay, and one thing that's going to play a role in these numbers is your cholesterol. So there's two types of cholesterol. We have the LDL, which is bad. It's going to cause a buildup of plaque. And so this plaque is going to make your arteries less flexible. And you want them to be flexible so that they're not under a lot of pressure. You want them to be able to expand. So this LDL you're going to get from eating, all these fried foods and butter and all that good stuff. But it's actually not good. It tastes good, but it's not so good for you. And then the other type of cholesterol is the HDL. This is known as the quote-unquote good cholesterol because it's like your healthy fats that they kind of act like a glue, and they come by in your vessels, and they kind of take some of that bad plaque with you, or to kind of clean it out. Just keep in mind that for example, avocado has good cholesterol, but you don't want to overdo it because anything or too much of anything is bad. So just you want to eat healthy fats, but you want to make sure that you don't eat too much of it, because it's still not going to have a very good effect for you. All right, let's see, we're almost getting there. Vessels. All right, so we're just going to do very basic of vessels for now, and then we'll go into the structure a little bit later. For now, you just need to know that arteries carry blood away from the heart. So arteries are away. These are going to be thicker and more elastic because they're going to have to withstand a little bit of higher pressure, because this is when blood is barely pumped by the heart. So it's going to have a lot more force with it. And then you have veins, and their job is to carry the blood to the heart. Veins have valves scattered in them, and this is to prevent blood flowing backwards. They're going to prevent backflow. Kind of like in the heart, you have valves to prevent backflow. It's the same thing in veins. And then capillaries, these are going to be your tiny, tiny vessels, basically just a single layer. But this is where stuff actually happens. So your arteries and your veins are carrying blood either away or to your heart, but in the capillaries, it's where the exchange is going to happen. So like, for example, the capillaries in your muscles, that's where the blood is going to pick up carbon dioxide and drop off carbon dioxide, and it's going to give out the nutrients and take the waste with it. So that's where stuff actually gets done. Okay, so you start at the heart, and then the blood is pumped out of the heart, and it's going to travel through the arteries. The arteries, as they get smaller, they're known as arterioles. And then you end up in your capillaries. So this is where gas exchange, nutrient exchange, and all that happens. And then the waste is going to be carried back. And it's going to happen in the venules, which are veins as they get a little bit bigger. And then you have the big actual veins, like your vena cavas and stuff, and they take the blood back to the heart. Okay, and so that about wraps up kind of the introduction. Next time we'll go over the actual pathway of blood in the heart and how the pumping is regulated and all that good stuff.